back to this handout. Now, as I talk about 7-2, I don't know if any of you have ever watched the old TV show ER. I mean, it's not on anymore. I think they just canceled it recently here. But I like to use this rule here. And notice I put, and I'm going to underline this here in a pretty green or something, this little rule here in this box for section 7-2 will carry you guys a long way, guys and gals. All right? And it says that, let's say if you have, I'm just going to use this box here, the cube root of x squared, that radicals are simply fractional exponents in disguise, that you can write this as x to the 2/3 power. Or the fourth root of y to the first power would be y to the 1/4 power. And notice I like to use the ER show as an example. I call this E over R, exponent divided by the root number. So if you know what's what, and you like the show ER, just remember that the root number always goes where? In the denominator. I missed that 4 on the first one, of the fraction. And the exponent underneath the radical always goes on the top. So that's a good way, and I put a whole bunch of other examples in there and stuff, and we will now play with section 7.2. Okay, so let me just clear this off here. And in section 7.2, they will start out with some friendly radicals, believe it or not, and they're going to go ahead and pull y'all's chain. They will give you problems like this, 64 raised to the 1/3 power. That's a bad 3 there, sorry. And they will want you to use radical notation to write each expression and then simplify. So we're going to go ahead and rewrite this, and remember that E over R rule if you want to. If they give you a fraction, you can just put that right next to each creature there, will be the cube root of 64 and to the first power. Now, of course, we know anything to the first power is itself. So this would just simply be the cube root of 64, which would give us 4. All right, fractions you ask, fractions. I know y'all are afraid of them. Let's do the fraction 1/16 raised to the 1/4 power. So if we wrote this in radical form, it would be, well, the 4th root of 1/16. And then if you want to think about that, it could be the 4th root of 1 over the 4th root of 16 using the quotient rule. I mean, I don't know how many of you like to do this, but we could certainly do it to simplify the process. And we would get 1/2. 4th root of 1 is 1, 4th root of 16 is 2. So they are going to play the ER game with everybody. All right, now let's try another one here that even gets more interesting. 4 raised to the 5/2 power. Now I know what y'all are thinking, well, Young, that's a piece of cake. It would be the square root of 4 to the 5th power, which is one way to do it. Now on ones like this, notice the numerator is larger than the denominator. You can also write this as the square root of 4, and you can take that 5 and put it on the outside of the radical. So I know some of you are going, why would you do that, Young? I don't know. Now, I don't really have my calculator with me here, but if I took 4 to the 5th power, isn't this going to be some extremely large number? And I mean, I'll get my calculator out. Hang on here. Let me pull it up. I'm going to say 4 to the 5th power is 1,024. So y'all check me on that. And the square root of 1,024 is 32. Okay, so let me write it this way. So if you wanted to do it the first way here, you will get this, the square root of 1,024, and if you do that on your calculator, you'll get 32. Whereas if you take the 5 and you put it on the outside of the radical, you could do the square root of 4 inside here first, which is 2, and then take that result and put it to the 5th power, and you still get the same answer. See, so which way do y'all like better? Do you like leaving the number inside or taking it outside? I mean, if I didn't have a calculator, I sure think I would like to do it the way on the right. But I don't know. We'll see. Now, let's do a few more here and see if we've got this rule here. How about 64 to a negative exponent? Y'all thought we were done with exponents, didn't you, in Chapter 5? The power rules are back. 64 to the negative 2/3 power. Now remember, how do you write something with a negative exponent? You bring it downtown, downtown, and it becomes positive in the denominator. Now we can use our rules for radicals and write this as 1 over the cube root of 64 squared, if you want to write it way 1, or 1 over the cube root of 64 and take the 2 and put it outside here. And either way, you will get the same answer. But again, if I don't have a calculator handy, which I really don't on this chat tonight, bad young bad, don't have his calculator, is 1 over the cube root of 64. I do know my friendly cube roots and square roots and fourth roots and stuff is 4, and then that would be squared, so you would get 1/16. Where you would get 1/16 in the other way too, but man, 64 squared is another big number, and you have to take the cube root of that, and it's not as friendly. So tomato, tomato, potato, potato, you know, be careful. Let me try one more. Now this one could get you. -9 in parentheses raised to the 3/2 power could be written as, well, the square root of -9 in parentheses cubed. So we'll put a little, make sure we got our E over R there. Now notice what kind of number this is going to be here. If I take -9 and cube it, y'all agree I am going to get something negative under here. I've got an even root with something negative, and not a real number. And I bet you your calculators will say error if you try it. See, I don't even care if you take that 3 and you leave it inside. I know what some of you are thinking, well, what if I take it and put it on the outside, young sucker? I say, all right, let's do it the other way. See, you still get the square root of something negative. Either way, it leads us back to the same path. So be careful of those negative exponents there. All right, and really this is it for 7.1 and 7.2. Now 7.2 is going to then really bust your chops on power rules. So y'all may want to take your handout. Now we haven't seen these since the early part of Chapter 5, so let me find it. I'm going to pull it up here. You know, we've got handouts for everything here in this class. And I think I can find this one faster because I have been using it for a while. It's loading as we speak. It sometimes just takes Wimba a few minutes or seconds to load a PowerPoint. And I think y'all remember this handout, the first part of 5. So you may want to refer to it. Look at those 5 rules. When multiplying same bases, add the powers. When dividing same bases, subtract the powers. Raising a power to a power, multiply, and of course your negative power rules, ones we've already discussed and talked about, are all in play here. So I'm going to take a few more of these, and we're going to have some fun with them. All right, so I think what I want to start with is one similar to as this. Let's take a to the 1/4 power times a to the -1/2 power, and divide that by a to the 2/3 power. Now y'all may look at that and go, I don't like these fractions. But anyway, we're going to treat them the same here. I think what I'm going to do first is use the 4th power rule and bring that downtown, downtown. So anytime I see negative exponents, I like to rewrite them as positive exponents. So here is step 2. All right, now what do I do in the denominator there? I've got a to the 2/3 times a to the 1/2. Well, y'all have to know that this is power rule number 1. And I'm going to put that so you can go back in the handout and go, what the heck was that? Whenever you multiply same bases, you must add the powers. So 2/3 plus 1/2 would be a common denominator of 6. And we would end up with 4/6 plus 3/6, changing these to common denominators. I'll do a little color here. So our next step would be to combine those a's in the denominator and get a to the 7/6 power. Now what, Young? Now what? Well, what's the rule now? Whenever you are dividing same bases, you must subtract the powers. So if I'm going to subtract these powers, well, I'm going to go ahead again, and it's the common denominator game. The least common denominator of 4 and 6 would be 12, and 1/4 would become 3/12. 7/6 would become 14/12. Now, which way do y'all want to subtract these? Do you want to subtract up or subtract down? Remember, you want to usually write your exponents as what kind of numbers? Positive. So since there are more a's in the denominator, I'm going to subtract the top from the bottom, and I am going to get 1 over a to the what power? 14/12 minus 3/12 would be the 11/12 power, and that is how they will write it. So it will say use the properties of exponents to simplify each expression and then write the answers using positive exponents. All right. So I'm going to give you lots of different looks here in our chat time tonight. We still got plenty of time here. There is the national championship game. It's Monday night here. It's Duke tonight against Butler. Cinderella Butler against Duke here. I don't know who's going to have the advantage there, but it should be an interesting game. I just hope I can stay up and watch it. Might be past my bedtime. I heard the tip-off not till 9 something. So, and even doing this chat, Young's eyes are growing sleepy. All right, let me try this one on y'all. So again, we are going to have to really work on those exponential rules. And that's a bad 8 in the top here. That's a 1/8 there. I'll try to make it a little better. All right, now both of these, what I would say do first is use power rule number 5. And this is good exam review. So whenever you raise a power to a power, do what with the powers? Multiply them. So if we multiply, so I'm just going to make a little note here on both of these. Multiply powers. I'll try to sneak that in here, and I'll put multiply here. Now remember, on this b in the denominator, we could put a power of 1 on it since it doesn't have a power. So here's step 2. Negative 2 times 1/8, and if you want to, you can come up here and do it. Negative 2 times 1/8 would be negative 1/4. B, 3 times 1/8 would be 3/8. All over A, negative 3, I'll come down here a little bit, times negative 1/4 would be positive 3/4. B, 1 times negative 1/4 would give us negative 1/4. So I know y'all love these fractions and stuff. I mean, they're just wonderful. So I use power rule number 5 first to get where I'm at. Now I'm going to sing a few bars of downtown and uptown girl. I'm focusing in on these negative exponents. So if it's negative in the top, bring it downtown. If it's negative in the bottom, bring it uptown girl. She's been living in an uptown world. And let's go down here a little bit and get some room and rewrite this problem as b to the 3/8. So if the power is already positive, leave it alone. The b to the negative 1/4 in the bottom comes up as positive in the top. The a to the negative 1/4 in the top comes down as positive in the bottom. And then you still have that positive a to the 3/4. I don't know why, but my 3's on the writing tablet tonight are not looking pretty. Go to the bottom. So we used power rule number 5 to get here. And to get here, we use power rule number 4, which is the negative power rule. And now, let me use some other colors. What are we going to do with the powers on the B's and the A's? Well, we will have to use power rule number 1 and add the powers. All right, so this should do it for us. So there's, these rules will never go away. I don't care what the numbers are, treat them the same. So if we take 3/8 plus 1/4, common denominator is 8. Whenever you add fractions, you've got to get a common denominator. So the first fraction, bottom don't change, top don't change. The second fraction becomes 2/8. So the numerator of this will be b to the 5/8 power. All over a to the first. 1/4 plus 3/4 would be 4/4, and you would get 1 in the bottom, and that would be your answer. So they are going to take fractions and make you all get good at them. And there's your final answer. All right, now y'all don't even appreciate yet why this E over R rule is such a great thing. Now, in the past, they used to have trouble with a problem like this. So I'm going to go ahead as my last example here, and I'm going to write the 5th root of b squared divided by the 10th root of b cubed. All right, now this says use rational expressions to write as a single radical expression. Now, remember, rational expressions are just fractions. So we're just going to take these radicals using our newfound friend E over R, and we're going to change that to b to the 2/5 power over b to the what? 3/10. Now, power rule 2 says, what would you do with the powers whenever you divide same bases? Well, you would subtract the powers. So if you take 2/5 and you subtract 3/10, we need a common denominator of 10 here. So 2/5 would become 4/10 minus 3/10. So it looks like our answer is going to be b to the 1/10 power. Now, if they wanted you to write that using rational expressions, there's the answer. But some of the problems will say write that as a radical answer. And if you wanted that as a radical answer, it would be the 10th root of b to the 1st. So you really have to watch out here for what the directions say to do. Okay? So if the directions on some will say write as a single radical expression, I'm going to put that for this. This would be what the directions want, the radical expression. If it says write with positive exponents, you would have this. All right, so that is a pretty brief summary of section 7.1 and 7.2, and I hope everyone gets kind of acclimated here to radicals. So this is Professor Bob Young signing off, virtual chat after spring break. Hope everyone has a great rest of the week and does well. If you haven't taken that third test on chapters 5 and 6, do well on that and start hitting these sections in 7 and 8, and that is all that's left, and we will be heading toward the exam at the end of the month. So early May, first week in May, it'll be exam time, and wow, the term is just flying. So hope everyone has a great evening and week. Good night.